Hello everyone, I am Tanushree from Sri Venkateswara College of Engineering. Today I am here to talk about the concept vector calculus. The agenda for today's topic is introduction, vectors and scalars, vector operation, dot product and cross product, gradient, divergence, curve, application of vector calculus, and conclusion. The first topic is Introduction to Vector Calculus. Vector calculus is a branch of mathematics that deals with the differentiation and integration of vector fields and functions. It extends the concept of calculus such as derivatives and integrals to functions that operate on vector. Key topics include gradient, divergence, curl, line integrals, surface integrals, and fundamental theorems of calculus for line integrals. Vector calculus finds applications in physics, engineering, and various fields involving continuous quantities and their interactions in three-dimensional space. The next concept is vectors and scalars. Vectors and scalars are fundamental concepts in mathematics and physics. Scalars are quantities that have only magnitude like temperature, mass, or time. Vectors have both magnitude and directions like velocity, displacement, or force. Vector operations. Vector operations involves manipulating vectors using mathematical operations like addition, subtraction, scalar multiplication, and dot product. Dot product and cross product. Dot product. Dot product is also known as scalar product. The dot product of two vectors measures their similarities or alignment. It calculates by multiplying the corresponding components of the vectors and summing up the result. The dot product results in a scalar value and it can be used to find the angle between two vectors and perform projections. Cross product. Cross product is also known as vector product. The cross product of two vectors yields a new vector that is perpendicular to the plane formed by the original vectors. The cross product results in a vector and it is commonly used in physics and engineering to find torque, angular momentum, and more. Gradient. The gradient is a fundamental concept in vector calculus that represents the rate of change of scalar field. It is a vector that points in the direction of a slope increase of the scalar field and has a magnitude that indicates the rate of change. Divergence. Divergence measures the rate of which a vector field spreads out from a given point in space. It helps us understand the behavior of vector field in terms of their source and converge. Curl. Curl measures the rotation or circulation of a vector field around a point. It helps us to understand the rotational behavior of vector fields. Applications of vector calculus. We are applying vector calculus in the field of physics, engineering, economics and finance, robotics, science, and more. The first application is physics. In physics, we are using vector calculus for electromagnetism and fluid dynamics. Electromagnetism. Vector calculus is essential for describing electric and magnetic field using Maxwell's equation. It helps analyze the electromagnetic waves, antennas, and circuit theory. Fluid dynamics. The concept of divergence and curl are used to study fluid flow, turbulence, and pressure distribution in fluids. Next is engineering. Mechanical engineering. Vector calculus is used in analyzing force, motion, and stress distribution in mechanical systems. It's crucial for designing structures and mechanisms. Aerospace engineering. It's employed to model aircraft and spacecraft trajectories as well as the behavior of fluids around them. Machine learning. Gradient descent, a technique from vector calculus, is used to optimize models in machine learning algorithm. Image processing. Vector calculus is applied to edge detection, image filtering, and other image processing techniques. 3D graphics. Vector calculus is used to manipulate and render three-dimensional objects in computer graphics, enabling realistic visual effects and animations. Next, in the field of economics and finance. Vector calculus is used in economics and finance to find optimal investment strategies by maximizing returns while minimizing risks. Next, in the field of robotics. Robot motion planning. Vector calculus aids in planning the trajectories and path of robots to accomplish tasks efficiently and avoid obstacles. Next, in the field of science, environmental science. Vector calculus assists in modeling atmospheric and oceanic circulation patterns as well as heat transfer in the Earth's system. Next is biomechanics. Vector calculus is used to model and analyze force, motion, and fluid flow in biological systems such as blood flow and muscle movement. Conclusion. Vector calculus is a powerful mathematical framework that extends the principle of calculus to vector field and functions. So thank you for watching this video.